This lesson is solving linear equations with fractional coefficients and identifying types of solutions. So here we go. So there's just one additional step here. The first thing we're going to try to do is clear the fractions. And you're going to be doing this over and over again so you'll get it. So you're going to multiply by a common denominator. It doesn't have to be the least common denominator, but a common denominator. Then we distribute. Combine like terms on a side, keep those sides separate, and then move. When you move, you use the opposite operation. Move the variables, move the constants. Make sure a coefficient of 1 is in front of the variable by multiplying or dividing. Check for reasonableness. Here we go. So on this one, 3 is the only denominator here. There it is. So I'm going to multiply everything through by 3. So I'm going to move it over here a little bit so you can see. So I'm going to multiply this guy by 3, the 4 by 3, and the 8 times 3. Okay? It's because when I'm multiplying 3 on the left-hand side, I'm actually distributing a 3 through. 3 divides out because 3 divided by 3 is 1, and we get 2y minus 12 is equal to 24. And now we're like, oh, I can do this. I can do this. So we're going to add 12 to both sides. So 2y is equal to 36. Divide by 2, get that coefficient of 1 in front of the y. Y is equal to 18. And we're lucky in this section that you can use your calculator if you need to. All right, now let's take a look at this next one. Well, we have 3 denominators here, a 5, a 3, and a 15. The common denominator is 15 because 3 and 5 both divide into 15, and 15 divides into itself. So over here, I'll write the original problem out because I think it'll be easier. So I'm going to multiply 15 on all 3 terms here, okay? 5 goes into 5 once, 5 goes into 15 3 times, so I'll get 3x is equal to, 3 goes into 3 once, 3 goes into 15 5 times, 5 times 2 is 10x, 15 divides out, plus 7. Now I move things around. Now in this case, I'm going to bring the 10x over to the other side as a negative 10x because the 7's already over there and I don't feel like moving 2 things. So I have 3 x's, I owe you 10. That means I still owe you 7 x's. Divide through by a negative 7 here. So x is equal to negative 1. Not bad. So what ends up happening is once you clear the fractions, you are golden, man. It's reversed back to what you did before. Okay, let's take a look at this next one. The 2 is the only denominator, so we are totally going to multiply everything through by 2. So I have 4 terms here, so I got to multiply them all by 2. So I'm going to get 2 times 7 is 14 with the x. 2 times 4 is 8. The 2's divide out, I just get an x. And 1 times 2 is 2. Now we do our shuffling. I'm going to subtract an x. So this is really 1x. Remember, you guys, don't panic. You can do it. Add 8. So we get 13x is equal to 10. Divide by 13. X is equal to 10 over 13. You don't have to do anything else with that. Okay. Now it seems strange, but it will check if you go through it. Now we're going to be doing types of solutions. There's 3 things that can happen. You can get one answer, no answers, and you get a false statement like 9 is equal to 4, or you can get all real numbers or an identity, okay? So here's the deal. Let's take a look. We're going to, solving the equation, state if the solution is an identity or if there is no solution, okay? So I'm going to state these answers two different ways if we get an identity, so that if my math lab says there's no real solutions, we'll state it that way, or they say it's an identity, we'll state it that way so you can see. All right, so we're going to solve these equations. I'm going to distribute. There's no fractions, so you're psyched, right? Yay. Everybody with me? 2x plus 8, distributing that 2. Now I'm going to subtract 2x from both sides. Oh, they both add out, so we get 9 is equal to 8. So this is false, obviously. And there's no variables left in the problem. So we have two numbers here hanging out, get a false statement, so there's no solution. Now let's do the next one. Again, I'm going to distribute. So 3 plus 2x plus 5 is equal to 2x plus 8. So I'm going to combine like terms. So 2x plus 8 equals 2x plus 8. I'm going to subtract 2x again. My x's will add out. So I end up with 8 equals 8. So this is true always. Okay. There's no x's in there. There's nothing. So this is true always. So that means the solution is all real numbers. What does that mean? That means I can put in any value I want for x and have both sides balance. Whereas in part A here, no value of x would work ever. Okay? So in part B, you guys, we can say the solution is all real numbers. Or we could call the equation is an identity. Okie dokie. Now in part A, there's no solution. We cannot find any x values. We say the equation is a contradiction. Cool? All right. Now what happens when you have variables in the denominator? So we do it the same way. We have to find a common denominator and multiply both sides by it. So in this one, we have two denominators that are different, 3 and x. So we're going to multiply those together, 3x. And again, I'm going to write it over here so that you have some room to write it out. So I'm going to do 3x here, multiply by 3x here, multiply by 3x here. Okay? Now the x's will divide out because x divided by x is 1. So I get 15. Now here the 3's will divide out, so I'm left with 2x. Here the x's divide out, so I'm left with 21 because 7 times 3 is 21. So I'm going to move stuff over. I'm going to move the 21 over to the other side. So I owe you $21, but I give you 15, so I still owe you 6. I'm going to divide by 2 on both sides, so x is equal to -3. Cool? And last but not least, I'm going to multiply both sides by 2x in this problem. So I'll just do this, move it over. Hopefully you're hanging in there. So I'm going to multiply both sides by 2x, 2x, 2x. So I'm going to get rid of that, divide it out. 1 times 1 is 1. 1 times 2x is 2x. And just keep in mind I'm multiplying these two things, so I get a -8x. I'm going to move that darn 2x over. I'm going to add it to both sides. So I end up with -6x is equal to 1. Divide by -6. X is equal to 1/6 negative. Now you might say, is it negative 1/6? Is the negative on the top? Is the negative on the bottom? Is the negative in front? Turns out, if you do a negative on the top, or you put the negative on the bottom, or you just stick it in front of the whole thing, these are all equivalent, and My Math Lab will take them all. Now you can do the lesson associated with these problems. Good luck. Ask lots of questions. You can do this.